Good morning. So today's lesson is the second one of our unit. We're talking about factoring polynomials. As you can see, this is something we're going to spend 2 days on, but today we'll just do the first part. Now, factoring polynomials, as I said yesterday, is just something that is a skill that's really important. We're going to be counting on this skill for the rest of this unit certainly, but also many more units to come as long as you continue to study math. So something that we just want to make sure we have a good foundation for. And I want to actually start factoring by just trying to explain what it is and why you would do it. And I mean, this is a nice definition here where it says to express a polynomial as a product of polynomials. So the idea would be to take something that currently uses addition and subtraction and to rewrite it in such a way that it uses multiplication. Now, you might be curious, like, why would that be important? Like, what is it about, 3x plus 1 and x minus 4, for example, versus the expanded version that's useful? Like, why is it useful to write, obviously these are equivalent, right? They're the same thing, but why is it useful to write it as two brackets multiplying instead of one equation? And the answer to that lies in what you can tell about two things that are being multiplied if the answer is equal to 0. Okay? So like right underneath here or something, I want you to write something like, if the answer to a multiplication question is 0, okay, then how do you multiply numbers together to get 0? This could only happen then at least one of the numbers must be 0. And this is hugely important because now you can go back to this picture and you can say, okay, if I ask you 3x squared minus 11x minus 4 and I say, how do you make this 0? It's going to be difficult to figure that out, right? Because you got to square the number, times it by 3, then times the number by 11 and subtract it, and then subtract 4. I mean, how are you going to guess what number works for that? It could take quite a while, and there's not really a straightforward way to solve it. You can use the quadratic formula, of course, but when you look at it in a factored way, and now you ask the question, how could this whole entire thing be 0? Well, the answer becomes much easier. Either the 3x plus 1 bracket is 0, which you could see would happen if x were equal to negative 1/3, right? If x is equal to negative 1/3, the whole equation is equal to 0. And the other equation is very easy to see when x is equal to 4, right? When x is equal to 4, the whole parabola is 0 because this second bracket becomes 0 when x is 4. So why would you want to factor something as answered by this statement here? When we want to set it to 0, which we do very often, it's easy to tell when a multiplication is 0. There's only one way for a multiplication to be 0. One of the factors is 0. On the other hand, when you're adding stuff, there's many ways for adding things to be 0. So this is why factoring is useful. This is also an excellent definition. It is the opposite of expanding. Expanding, yesterday we talked about getting rid of brackets. Factoring is about creating brackets. It's about getting rid of all the addition and subtraction that is outside of a bracket. So if you look back at my factored form here, let's just get rid of some of these things. Notice that in my expanded form, everything is joined by addition and subtraction. In my factored form, every addition and subtraction is inside a bracket, and that's the way it has to be for something to be factored. Okay? So they're opposites of one another. They're opposite processes. When you've factored something fully, you'll know that because every plus and minus is inside a bracket, and there are only 1 or negative 1 that are common factors within each bracket. So let's just review on, how do you do common factoring, which is the first part here. To do common factoring, what you do is you look at each term, and factor out any common common factors, i.e. things that can multiply into both terms. So here, we're looking at 3x and we're looking at 12. Now, 3x has an x to donate, but 12 does not. So x is not a common factor here. The common factor here is 3, right? And if you divide both terms by 3, what you would be left with is x plus 4. Again, you can easily check your work here by just distributing the 3. You distribute the 3 onto the x for 3x and the 3 onto the 4 to get 12. And you can always work backwards to get from 3x plus 12. You can work forwards by factoring it. You can work backwards by expanding it, right? So I'm just going to write underneath, check your work by expanding, right? That's what you would do. Now, when you go to this second one, any common term is a common coefficient like it was the first time, but you're also looking for variables that are in common. So when you look at this one, you could look at the numbers first, and you see that between 4 and 8 a common number is 4. Between x squared and x a common factor is x. Between y and y squared a common factor is y. Now when you go into this to make the rest of it, you have to ask yourself, what is left of this first term when I've divided the 4 out? Okay, so 4 divided by 4 is 1. You don't have to write the 1, but I'm just going to write it here to remind us what we're doing. X squared divided by x. Well, remember, x squared is x times x. If you divide by an x, it's like you've canceled one of them out, right? So you have 1x left. Y divided by y is just equal to 1 again, which I am not going to write down. So when you factor that first chunk, what's left is strictly x. When you go to the second chunk, you have 8 divided by 4 is 2. X divided by x is 1. It cancels out. I'm not going to write 1. And then y squared is 2y's, like y times y. And then you're dividing by a y, so you have y times y divided by y. 2 of those y's cancel. You're left with a y, a single y there to check. Now, you can expand this to work backwards and check your work, but another useful thing you can do here is you can use GeoGebra for this. So we have 4x squared y plus 8x y squared. Okay, and it creates this thing. It creates a function that has 2 variables, but we don't really need to worry about that. I just want you to concentrate on what we got there. Then we're going to factor a. And you can see that GeoGebra has no problem factoring this. It gets the same answer that we got. It put the y first and the x second, but since it's multiplying them, it doesn't matter what order. Then we can go expand b, right? So I want to expand this function called b, and it just goes back to what we had before. So factor, right? Factor a would factor the function called a, and then expand b expands the function called b, and this is a really good way to check your work if you want to. We go over to this last one. We notice that 8, 6, and 4 can all be divided by 2 and no higher number. X cubed, x squared, and x squared can all be divided by x squared, right? And then I'm looking for y's, but this one has a y, this one has a y squared, and this one does not have a y to give at all. So you can't factor something unless everything is able to give it. So here we've got 2x squared, so we're going to do 8x cubed divided by 2x squared. Okay, now 8x cubed, okay, so let's go f of x, let's just restart this for a second just to show you what I'm doing here. F of x is 8x cubed. Change the font back quickly, sorry. Forgot it doesn't save that. And then we're dividing it by 2x squared. So g of x equals 2x squared. So we have f over g, right? So this is what we're doing. 8x cubed divided by 2x squared. Now, when you actually do this division, so I'm going to write simplify h. It simplifies down to 4x, right? Because 8 divided by 2 is 4. X cubed means you multiply x 3 times. X squared means you multiply x 2 times on the bottom, right? So what you have is something like, you have something like this. Let's quickly write this out. 8x x divided by 4 or 2xx, right? You have something like this. Something that looks like that. And really what you're doing here is if an x is on the top and the bottom, you can cancel it out. So you cancel this one, you cancel this one, you do your 8 divided by 2 is 4, and that's why you're left with 4x at the end of that process. Okay? And we go to the next one. We have 6x squared y squared divided by 2x squared. Okay, 6 divided by 2 is 3. X squared divided by x squared is 1. Y squared, there is no y squared being divided, so we just leave the y squared alone. We go to the last term. 4x squared divided by 2x squared is 2. The x squareds cancel, and the y is still there. Okay, so that's what you should get for your answer on that one. And again, you can check that work by just using your distributive property to work backwards. Okay. Now, the other type of factoring we're doing today, we're doing two types. So we're doing simple trinomials, which is here, and then we're doing complex trinomials, which is a little more involved. When you are doing simple trinomials, okay, they always look like this. ax squared plus bx plus c. A, b, and c are coefficients. They are not variables. Remember, x is the variable. A, B, and C are simply the numbers that are in your question. So A is the number that goes here at the front, B is the number that goes with X, including this sign here, and C is this number, including the sign here, positive or negative. So in this first one, A is 1, B is 8, C is 12. What you are looking for is you are looking for two numbers that add up to 8 and multiply to 12. That's how you're going to factor this. Again, do not think about numbers that add up to 8. There are a million numbers that add up to 8. There aren't that many numbers that multiply to 12, right? You think about 12. 12 could be 12 times 1. It could be 6 times 2. It could be 4 times 3. That's it. Of course, it could be the negative versions of all of these, right? So let's say plus or minus of each of them, right? So it could be, negative 1 and negative 12, for example, or negative 6 and negative 2, right? But, it can't be any other combination other than these three. So now I look at these three, and I look at the one that adds up to 8. And of course, the one that I'm looking for is the positive, right, 6 and the 2. Those are the numbers I need. To answer your question, what you say is you open up two sets of brackets, okay, and then you say x, you put an x in each bracket, and then you put the two numbers that you found. The two numbers we found were a plus 6 and a plus 2. And now what I've done is I've taken the original equation, right, and I've written an equivalent expression that is factored. Every addition and subtraction is inside a bracket, and there are no common factors inside my bracket. Again, GeoGebra is helpful for this sort of thing. That's my original question. It named it Q. I type factor Q, and it comes up with x plus 2, x plus 6. Keep in mind, because this is multiplication, the order that these two factors show up in doesn't matter. Either order would work. You could do x plus 6, then x plus 2, or x plus 2, then x plus 6. Okay? That's how you factor a simple trinomial, and these are fairly straightforward. You just, get used to looking for these combinations of numbers, okay? This next one, I'm just going to push on to a new page. Sorry, we'll move this back to the old one. This next one, I'll just push on to a new page just so we have more room to work with it. So we have x squared minus 9x plus 20. Again, our a value is 1, our b value is negative 9, our c value is 20. So these things, they cap out here at 15 minutes, so I'm going to pause here and it'll just go to the next one and we'll pick up from this spot.